The trick to adding and subtracting rational expressions that involve variables or polynomials or monomials is that you have to have common denominators before you can add or subtract, just like you always used to when you had constants or just single numbers. Our first couple of examples here have common denominators already, so they really amount to combining like terms. A little bit later on, we'll have to find a common denominator first. Here we just have 8/7 minus 2/7. That gives us 8 take away 2 is 6/7. And then 6/7 plus 4/7 equals 10/7. And here we have 4x squared minus 3 over x plus 5 plus 2x squared minus 1 over x plus 5. So our denominator stays the same, it's constant, x plus 5. And then our numerator, we're just combining like terms. We have 4x squareds and 2x squareds gives us 6x squareds, and negative 3 and negative 1 gives us negative 4. That's it. Example C, we still have common denominators already, 2x plus 3 and 2x plus 3. So really we're just combining like terms again on top. Our denominator stays 2x plus 3. And then our numerator, we have x squared minus 3x squared. So we have negative 2x squared. And then we have negative 2x minus negative 3x. So that's going to be positive x. And positive 1 minus positive 5, it's going to be negative 4. Now we could test and see if this factored. We're not going to be able to factor the bottom. We could do 2 times x plus 1.5, but that's not really going to help us much. In the numerator we could do, nope, not going to be able to factor anything that matters. So this is as small as it gets. Sort of the first step along the road toward being able to add and subtract rationals that have different denominators is practicing finding the least common multiple of polynomial expressions. So to do that, the first thing we want to do is factor. So we're going to take these two expressions and factor them first so that we can find the least common multiple of them. This one, everything has a 2, so we'll plot a 2 first. Get 2 times x squared plus 4x plus 4. That looks like a perfect square trinomial. So that would be 2 times x plus 2 squared. And then the other one has a common x, so we'll plot an x first, and we'll get x squared minus 4x minus 12. And then this looks like positive 2, negative 6. So x times x plus 2 times x minus 6. And then the least common multiple of a polynomial expression pair is the highest power of each individual factor from both polynomials. So we have a 2 here, so our least common multiple is going to have a 2. And we have an x here, so it's going to have an x. To have, say, x plus 2, this one has an x plus 2 squared, and this one just has an x plus 2. So the highest power is squared, so it's going to have an x plus 2 squared. And then we have just an x minus 6 over here, so an x minus 6. I know that seems a little obnoxious, but we're actually going to leave this in factored form like this because then we'll be able to later, as we're using this in division problems, it'll be easier to actually cancel things numerator to denominator because it'll already be factored.